All right, so chapter 9 is conic base in the beginning. We're going to actually group chapter 9 into two parts, 9:1 to 9:4, and then 9:1 to 9:3, sorry, and then 9:4 to 10:1 will be that last test. So 9:1 and 9:2 and 9:3 are all about conics. The first one is about circles and parabolas, which is what 9, okay? So a conic is a section that's formed from the intersection of a plane and a double napped cone. So this double napped cone is like an hourglass shaped figure. If you take a plane or a rectangular shaped or square shaped, and you slide it through the double napped cone, it's in different ways, they form these different kinds of conics. So if I were to take one and slide it through horizontally, then I get this circle, okay? It's a perfectly shaped circle. If you take it and slide it through, either like from left to right, so all the way through at a slant like this, you get an ellipse or an oval. If you chip off the edges of them, so something like this or the same thing on the bottom side, where you're just doing either through the top and part of the side or the bottom and part of the side, you get your parabola shaped. And then if you were to slide a plane in vertically, you would get two parabolas that like point away from each other, and those are called hyperbolas. So by the time we get to 1-3 in this chapter, we'll have gotten through all four of these different kinds of conics. Today is just the circles and the parabolas, which we have done before. Okay, a couple variations on it, but we have done the circles before. It's been a little bit since you've seen it. So a circle is a collection of all points x and y that are equidistant from a fixed point hk. That fixed point hk is your center, r is your radius, and the standard equation, which is the first one you've got to know from this chapter, is x minus h squared plus y minus k squared equals r squared. So you're going to get either one or multiple equations for each of the conics that we're going to cover. This is your circle one. So example 1 says the point 1,4 is on a circle whose center is at -2, 3 as shown in the figure. Write the standard form of the equation of the circle. So the figure just reinforces it this time. They could have given you just the figure or just the written information. It's just kind of backing it up. So your job is to create the equation based on the information that's there. So we just said the standard form is x minus h squared plus y minus k squared equals r squared. And what we do is plug in for h, for k, and for r. So if you look at the information that's given to you, what's already provided that's part of this equation? The h and the k, right? So we know the center is hk, which means this is x, minus a -2, which is +2, squared, plus y minus a -3, which becomes +3, squared. What we don't know yet is the radius. Now there's a couple ways to find the radius. What's one way? Ashley. Okay, you could do the distance formula from the center to the side. So remember, distance formula would be the square root of x2 minus x1 squared plus y2 minus y1 squared. And I can use either point as your x, y, or h or k in the distance, but just know that you have to use both of them. So if I started with x, y here, then this would be 1 minus a -2, which is +2, squared, plus y2, which we're calling that 4, minus a -3, which is +3, squared, 3 squared, plus 7 squared, 9 plus 48, square root of 50, sorry, that's 59, 59, square root of 58. Now, if it actually wanted the actual answer, like if it said what's the radius, then I would make sure that that's simplifiable. This one's not, but I would make sure that that square root can't be reduced. But I don't need to just give the radius. I mean, by itself, it's actually asking me for my equation. And what do I do with the radius when I plug it back into the equation? You square it. So this just becomes 58. So if it just asks for the equation, you don't even have to go through the work of trying to simplify it because you'll end up squaring it at the end. Good so far? The second way to find the radius. So if I start with that initial equation being x plus 2 squared plus y plus 3 squared equals the radius squared, do I have the x and y I could plug in? Yeah, so that's the other way you could do it. You could take the one that they gave you, which is that 1, 4, and plug it in place of the x and the y. So it would be 1 plus 2 squared plus 4 plus 3 squared equals r squared, and I'd get 3 squared plus 7 squared, 9 plus 49, which is 58. And then I could do the same thing I did. I don't even have to square it because it's already squared. So you could choose either one. If what they gave you, center and point, was horizontal, you could just count it. Or center and point was vertical, you could just count it. If they gave you diameter, you would have to cut it in half, right? So think about all the variations that you can get on that kind of question. All right, example 2 says to put the equation into standard form. So the ultimate goal here is to sketch the circle given by the equation and identify its center and radius, but this equation is not in standard form. Do you remember how we get equations in standard form? You got to complete the square. And because it's x squared and y squared, we got to complete the square twice. Okay, so if you need to brush up on your complete the square skills, we did this in chapter 2, like 2-1. You can go way back. Okay. But, quick refresher, I'm going to group together the x's. So I'm going to say x squared minus 6x. I'm going to leave the space because I want to fill that in. I'm going to group together the y's. And then I'm going to bump the 6 to the other side. And then to find that, first of all, I would check to make sure there's nothing on the squared terms. There's not this time. If there was, I would have to take that out. And then I've got to find the middle term or the last term by taking the middle term, dividing it by 2, and squaring it. So here I'm going to do 6 divided by 2, which is 3. And then I'm going to square it, and I get 9. And I'm going to add it to inside the parentheses and also balance the equation by adding it to the other side of the equation.
How'd you get the 9 again?
Take the middle term, which is that 6, divide it by 2, and then square it. Natalie. No, when you're doing it on the same side of the, the 6, you mean, when you divide it by 2? It doesn't matter because you're going to square it. Okay. So you can, but it will always go back positive once you square it. And then I got to repeat that process for the y. So I'm going to take 2, divide it by 2, I get 1. 1 squared is 1, so I'm going to add that inside the parentheses here and also to the other side of my equal sign, so I'm balancing my equation. With me so far? Yeah? Okay, so now my goal there was to make those perfect square trinomials, which means I'm going to factor it. When I factor a perfect square trinomial, I square root the first term, I square root the last term, I take the sign from the middle, put it in the parentheses, and square it. So if I do that with what's there, square root the x squared, I get x. Square root the 9, I get 3. Take the sign from the middle, which is negative, put it in the parentheses and square it. Plus, the same thing here, square root the y squared, that's y. Square root the 1, that's 1. Sign from the middle is minus, put it in parentheses and square it. And then add these 3 together, negative 6 plus 9 plus 1, which is 4.
Pardon the interruption, but Valerie Cervedio.
All right, so now I've got it in standard form. From there, I need to identify my center and my radius. So what's the center? 3, 1. Good. Change the signs on what follows the x. Change the sign on what follows y. And what's the radius? Good. Square root it so it's 2. And then I got a graph. Now I'm going to graph my circle. So I start at my center, which is 3, 1, to the right 3, up 1. And then my radius is 2, so I count to the right 2, up 2, left 2, down 2, and then best as you can connect those points. You'll see this again as an example when we get to the end, but variations on complete the square. Remember, if there was a number on the front, so like let's say that said 3x squared minus 6x, and then ignore the rest of it. But let's say it said that first. Then before I can find that third term, I have to take the 3 out. By taking the 3 out, I would divide both of those terms by 3, making the middle term -2. Then I would take the 2, divide it by 2. It's 1, square it, it's 1. I would add the 1 in here. Before I add the 1 to the other side over here, I have to multiply it times the 3. So you have to account for whatever was taken out on the front of your parentheses, which means sometimes you're actually going to end up changing the sign, because if I took out a negative number, it's flip it. So make sure if you're going to take something out of the parentheses before you complete the square, that you multiply it times whatever is being added to the other side. Again, at the end of the notes, we'll have an example one like this, but just so that you can keep that in the back of your mind. All right, x and y intercepts. So it does not matter what shape or graph it is. You find your x and y intercepts the same way. How do I find the x-intercept of a graph? Make y 0. How do I find the y-intercept of a graph? Make x 0. So let's start with the x-intercepts. Okay. X minus 4 squared plus 0 minus 2 squared equals 16. X minus 4 squared plus -2 squared equals 16. X minus 4 squared plus 4 equals 16. X minus 4 squared equals 12. And then I would need to square root both sides of my equation, but I have to remember to do what when I do that? You remember your even root property tells you plus or minus. So x minus 4 would equal plus and minus the square root of 12. So x equals 4 plus and minus the square root of 12, which is 4 and 3, or 2 root 3. So that means you have 2 x-intercepts. 4 plus 2 root 3, 0. 4 minus 2 root 3, 0. Okay, then I have to repeat that whole process for the y-intercept. So this time I'm making x 0. 0 minus 4 squared plus y minus 2 squared equals 16. -4 squared. 16. Subtract that 16. I get 0. So what happens when I do plus and minus the square root of 0? Is there such a thing as positive or negative 0? Nope, it's just 0. So there's only one y-intercept. So if you think about what would happen if I moved a circle around a graph, there could be 2 x's and 2 y-intercepts. There could be one of each. There could be none, or none of one, none of the other. It doesn't matter. But my advice is if you've got extra time, this would be when it's helpful to kind of just draw yourself a picture of what that graph should look like and see if it's consistent with what you just found. So I know my center is 4, 2, and I know my radius is 4. I go right 4, left 4, up 4, 1, 2, 3, down 4, which is consistent with 2 x-intercepts and 1 y-intercept. All right, second part of this section is parabolas. So just like circles, we've talked about parabolas before. However, we're using a different formula this time. So we're going to be using the standard form of a parabola in a different way. We're going to be talking about something called a vertex. Well, we know about the vertex. We're going to talk about something called a focus and a directrix. So if you were in Algebra 2 Honors, you dove pretty deep into these just like we will. If you were in regular, you touch the surface, but that's where it's going to feel a little different because we don't dive too deep in regular Algebra 2, okay? So a parabola, by definition, is the set of all points x, y in a plane that are equidistant from a fixed line, which is called the directrix, which is here on my graph, and a fixed point, which is called the focus, which is here on my graph. The midpoint between the focus and the directrix is the vertex, which is here on my graph. And the line passing through the focus and the vertex is called the axis of the parabola, which is here. So we, in this year, have talked about the axis and the vertex. This is the first time we're talking about focus and directrix. So it says that the directrix and the focus are equidistant from any point on the parabola, which means that this is the same as this is the same as this, and also this is the same as this. So if I go along the axis of the parabola, then the distance from the vertex to the focus and the vertex to the directrix is the same. This is where, if that's horizontal or vertical, it's easy to just count that distance. There are 4, technically, standard equations of a parabola. However, if you just know one of these, you should be able to alter it to get to the rest. Okay? The standard form of an equation of a parabola with a vertex hk, so this is a vertex other than the origin, is x minus h squared equals 4p times y minus k, and p can't be 0, otherwise there's no second variable. And this is an equation because the x is squared. This is an equation that's either going to go up or it's going to go down. If x is squared, it points up or down. The second one is y minus k. Again, y goes with k, x goes with h. So y minus k squared equals 4p x minus h. And this is a parabola that either points right or left. The focus lies on the axis p units from the vertex. So the focus is always along the axis, which means it's going to be either vertical or horizontal from your vertex. And it is p units from the vertex. If the vertex is 0, 0, then the equations become these. Just x squared equals 4py. Again, that would open up or down. Or y squared equals 4px. That would open right or left. So all that gets eliminated from there is the h and the k because the h and the k would be zeros. So if you just memorize the first 2 equations, you should be able to get to the second ones by knowing that the h and the k would be zeros. Okay, so look at graphs and let's talk about how do I find p and all that good stuff. So this first one is a vertical parabola, which means this is an x squared parabola. If the p is positive, then my equation opens upward. If the p is negative, then the parabola opens downward. In both scenarios, the distance from vertex to focus or vertex to directrix is still p. The difference is where does the vertex and the focus go. The focus always goes inside the curve and the directrix always goes outside the curve. So that your parabola cannot pass through your directrix. It always points opposite the curve. If my parabola opens downward, the distance here is still p. The distance here is still p. The difference is that obviously the focus is underneath the parabola because it folds around it. These are y squared equations. They point right or left. If the p is positive, it points right. If the p is negative, it points left. Still the same concept. The distance from the vertex to the focus and the vertex to the directrix is the same. And again, the parabola folds around the focus and points away from the directrix. All right, so these say, and they'll give you all sorts of different kinds of information. Sometimes they give you the directrix, sometimes they give you the focus, sometimes they give you the vertex with one of those, or they give you the focus and the directrix. So you got to be able to kind of look at the information that's given and decipher it a little bit. It says find the standard form of the equations of parabola with A, vertex at origin and focus at 0, 4. For me, I'm a visual person. I usually draw it out before I even start anything because it gives you a good indication of what you're going to do. So if I have my axis and my vertex is at the origin, my focus is 0, 4, which means I'm not moving right at all, but I'm going up 1, 2, 3, 4. So my parabola is going to look something like this. And from just taking that 30 seconds to draw it out, you should be able to identify a couple of different things. Because this is pointing up, what variable is squared? X is squared. And it's up, which means what's the sign on P? Positive. And if I count the distance from the vertex to the focus, what do I get? 4. That's P. So I know it's a positive 4 because it points up. I know my vertex is at my origin and x is squared, so this is going to be an x squared equals 4py equation. And I get x squared equals 4 times positive 4 times y. So x squared equals 16y.
How do you know it's x squared?
If it points up or down, it's going to be x squared. If it points right or left, it's going to be y squared. So you can try to do that in your head. You can say, okay, vertex is at 0. 0, 4 is above it. That means it's going to open upward. Count the distance in your head. But that's when mistakes are made. So my advice is to take that literal 30 seconds to draw yourself your picture of your parabola because it will help you. Okay, so look at B. Vertex again at the origin. This time focus is at 1, 0. So if I draw my coordinate points at 0, 0, and this time 1, 0, which direction is this parabola going in? To the right, which tells you which variable is squared? Y. What's the sign on P? Positive. What's the distance between the vertex and the focus? 1. So this is a y squared equals 4px. Y squared would equal 4 times positive 1 times x. So I get 4x. If it was pointing left, the only thing that would change is the negative on the 4 at the end. All right, now it says find the vertex, the focus, and the directrix of the parabola. So we flip-flopped. Before we gave you that information, you wanted the equation. Now we're giving you the equation, and you want to find that information. So what do I have to do first with this equation? Is it in standard form? Nope. I got to get it into standard form. Okay? So how do I get that into standard form? Complete the square. This time, there is something attached to the x. So this would get here. And I would actually bump the 1/2 to the side with the y. So y minus 1/2 equals, I got to take out a negative 1/2. And by taking it out on the first term, you also have to take it out on the second term. So 1/2 divided into negative 1. Keep, change, flip. And I get a positive 2. So negative 1 divided by the negative 1/2 became positive 2. Now I've got to complete the parentheses. So I take the 2, I divide it by 2, that's 1, square it, that's 1. So I'm going to add 1 inside the parentheses.
How do you get x squared plus 2x?
So I took the 1 that was there and divided it by the negative 1/2. Now normally I would add 1 over here to the negative 1/2, but I took something out, so I have to account for it. So instead of adding 1, I have to do 1 times a negative 1/2. That's actually negative 1/2. And that's what I have to add on to the negative 1/2. So negative 1/2 plus negative 1/2 is what? Negative 1. So this becomes y minus 1 equals negative 1/2 x squared plus 2x plus 1. Now I put that into perfect square trinomial form, so I'm going to factor it. Y minus 1 equals negative 1/2. Square root the first term, square root the last term. Take the sign from the middle, put it in the parentheses, and square it. Now already I know my x is squared. I'm going to have a vertex this time, so if you want to like think back to what that standard form is, it would be x minus h squared equals 4p y minus k. So compare that to this. I could switch the order if that's what you want to do. That would be negative 1/2 x plus 1 squared equals y minus 1. Now the right side's on the right side. But what else do you notice between the difference of what I have and what my standard is? Good. There's nothing on the front of this squared term. So whatever's on the front here, which is that negative 1/2, I have to get to the other side. So what would I do? You'd be dividing by negative 1/2, right? Or multiplying by negative 2. So I get x plus 1 squared equals negative 2 times y minus 1. So if you have a term on the front of the squared side, you've got to move it. And I want this side written like this. I don't want to distribute the negative 2 in. There can be nothing on that y either. If there's something on the y, I have to take it out as well. I think there's something like that in the homework. You'd have to take it off the y. Okay, now all of that was just to get it into standard form. So from there I can find the from there I can find the vertex, right? Vertex would be negative 1, 1. And then negative 2 equals 4p. So p would equal negative 2/4 or negative 1/2. This is a parabola with a vertex at negative 1, 1. It's an x squared with a negative p, which means this points down. So if I want to find the focus, I need to subtract the p from the y value, because that's what's going to move it up and down. So I have to take my vertex and I have to do 1 minus 1/2. So my focus is negative 1 and 1/2. And my directrix is going to be a horizontal line that's 1/2 above the vertex. So for the directrix, I have to take the y and add 1/2. So this is a y equals 1 and 1/2, or y equals 3/2. Obviously, that's probably one of the most complex ones. You have to get it in a standard form, and then you've got to be able to like pick it apart so well that you know where the focus goes, where the directrix goes, and then how to find it. If this parabola was turned sideways, then I'd be adjusting the x value of my vertex to get the focus and the directrix, okay? So think if it's vertical, then the p gets added or subtracted onto the y coordinate of your vertex. If it's horizontal, then the p gets added or subtracted from the x. Yep.
How do you get the focus?
So I know like based on what I know about this equation, I drew my graph, right? So I know my vertex is negative 1, 1, and I know that it's x squared, so it's up or down, but the p is negative, so it points down. So I know focus is below the vertex, and the focus is going to be p distance away from the vertex. So because we found p to be negative 1/2, I'm going to take, and actually that doesn't even matter, the negative on that doesn't matter. I know that if it's negative, it's below it. So I have to take the vertex y coordinate, because that's what's going to shift it vertically, and subtract the 1/2 from it so that it goes 1/2 below where my vertex is. Add the 1/2, it goes 1/2 up. That's where my directrix is. Does that make sense? Okay. I think that's the hardest of the section, to be honest. I mean, with the combination of the complete the square and all that stuff. So we'll end easier. Okay, example 6 says find the standard form of the equation of the parabola with vertex 1, 3 and focus 1, 5. So now we want the equation. We're given vertex is 1, 3, focus is 1, 5. What's my parabola look like? Points up, right? Which tells me this is an x squared, and it tells me it has a positive p. What is p? What's the distance from 3, God bless you, from 3 to 5, or from 1, 3 to 1, 5? 2. So p is positive 2. So now standard form is x minus h squared equals 4p times y minus k. The vertex is 1, 3, so this is x minus 1 squared equals 4 times a positive 2, 8, y minus k, which is 3. If I had asked you for the directrix, could you tell it to me? What is it? How far do I have to go from my vertex? Good. I have to go down 2 places, so y would equal 1. Your directrix is a line. It has to have an x equals or a y equals. Obviously, if it's horizontal, it's y equals. If it's vertical, it's x equals. Has to be a line, so it has to have the variable. Questions. So obviously you're going to get different variations on this types of information. You've got to be able to figure it out. So if this whole equation, if this question had started with the vertex being 1, 3 and the directrix being y equals 1, you would have gotten the same answer. You would have had to start with your vertex 1, 3, directrix being y equals 1. That means it points away from it. I would have counted p the same way. And you would have plugged it in and gotten the same equation. So they can give you vertex and focus, vertex, directrix, or directrix and focus, in which you'd have to find the midpoint to get the vertex. Questions?